actually, so I actually want to. We're gonna do. I'm gonna talk at you a little bit, and hopefully less than I'm even planning. And then we're gonna spend some time going through an exercise. Has anybody here heard of co-production of knowledge, co-production research? Oh, I need to hold this up. Now that's probably better. Has anybody heard of co-production or co-production of knowledge or that term? Well, it's pretty intuitive, sort of self-explanatory. Co-production, it's this idea, it's sort of a social science term that I think the easiest way to summarize it is it's probably better to do science with people rather than do science at people. If you want to do something that's useful in research, you probably ought to work with the people who are going to be using the thing that you're developing. So we're going to do a mini practice round of co-production today. If you look in your packet, it's behind number 6. There's a couple of sheets, and I'm just going to show you what they are now, and then I'll talk a little bit. So there's a brief description. You can skip over that for now, just as a reference. The co-production part is this questionnaire. We're going to sort of talk in our groups for a little bit and go through these questions in about 15 minutes. And I'm calling it co-production. I'm sort of joking because it's not real co-production. We're just going to spend 15 minutes doing this. But because I'm open to learn from you today, I want to collect these at the end of the session. We've been doing some research in an attempt to do something that's useful, and I'm hoping that sort of part of this conversation today can both sort of help you learn about what we're doing and ways to think about using it, but also help me learn about how you might use it and how we might be doing our work better. And then after that, just since you're looking at your packets, there's a couple of screenshots of this online tool we put together based on some projects as an easy way to browse, or hopefully easy way to browse our results. You'll tell me if it's actually easy. So that's it. Just wanted to make sure you know that's there and you're oriented to it. We'll get back to it in a few minutes. So I want to start by just giving you some background. So I'm going to talk about climate change and stormwater, but I'm actually going to talk about one specific aspect of climate change and stormwater, and that's heavy rainfall and how the intensity of those events is projected to increase based on models and what we've been doing to try to quantify that. So, there's other ways that climate change could affect stormwater, both direct and indirect. I'm not going to talk about those. Some examples would be sea level rise or changes in forest health or wildfire risk and their consequences, so on and so forth. There's other things we could be talking about. I'm just going to talk about heavy rainfall today. Okay, so I want to give you some background. So I'm going to start with, do I point this that way probably? There we go. The just basic climate change storyline, I think of this as sort of like the boring slide about climate change, but a good starting point nonetheless. So I want to go way beyond this, but this is just sort of to give you the basic state of what we're thinking about when we're thinking about climate change. On the left, you're looking at temperature change over the next 100 years in those colored lines. And there's different colors lines based on how much we assume humans emit in terms of greenhouse gases in the future. But they're all showing a huge increase. If you just, there's a whole bunch of squiggles. We call these spaghetti plots. If you look at just kind of sort of blur your eyes, the width of those squiggles, that's sort of the range of, some years are warmer, some years are colder. That's sort of the range that we've seen in the past and that we're going to see in the future. Basically, by the end of the century, no matter how much we emit in terms of greenhouse gases, either of those two scenarios, we're outside of the range of what we saw. So our hottest years in the past are about on par with our coldest years of the future. So it's a totally dramatic shift in terms of temperature for our region. We're in a completely different regime. On the right here is precipitation. So this is just annual total rainfall. So not as interesting from a stormwater perspective, and I'll get to that. If you just look at total annual rainfall, there's not much going on. You could probably squint your eyes and say it seems like it's going up a little bit, but it's so small compared to that envelope, you're not going to know the difference, right? So on an annual basis, we're getting basically the same amount, according to our models, getting about the same amount of rain as we used to get. No change there. So it's temperature is big change, precipitation is not a big change. All right, and this used to be, 10 years ago, when we were talking about climate change impacts in our region, this was kind of the end of the story. So we would say if you live in an urban area that's not downstream of some big snow-capped mountain, don't worry about climate change because temperature is the only thing that matters. The only way stormwater is going to get affected is if you got less snowpack and that leads to more flooding. And that was because of this picture right here. We were looking at the annual rainfall, no real change. So that picture changed because we were basically missing a big part of the story. We were looking at annual rainfall. We weren't looking at the most intense events. Turns out, even though annual rainfall is not changing, one of the things that's become really clear with the models in the last 10 years is that those heavy events are increasing. So if I can, I'm going to skip that. We can go back to talk about 2015 later if you're interested. So this is one example, just looking at average year stormwater people, so I got to tell you what metric we're looking at. This is the top 1% winter rainfall, daily rainfall events. If you look at just that number in the models, looks like they're increasing by about 20% by the end of the century. So if you used to get 4 inches, you're going to get something more like 4.8 or almost 5 inches in a 24-hour rain event. So that's just that. It might be different for hourly precipitation, might be different for 2-day precipitation. But so these are clearly increasing. It's not the same story as for annual precipitation, where there's really not much change. Okay, so that's where we started. That was the starting point. I want to get a little wonky with you for 1 second and talk about how we know or how we estimate these changes. So if you've read the news about global climate change, you see in these news articles they talk about global climate models. Global climate models are sort of state-of-the-art models for simulating what the climate does. You tell them, basically what you tell them is that the sun rises and sets, we're at an angle in our orbit relative to the sun, and we've got continents and oceans. And it figures out the rest. They figure out night and day. They figure out that there's sea ice in the Arctic, and it grows and retreats, and they figure out snow on the mountains. They do all those things, right? They get storms. So they're not perfect, but they're really sophisticated. One of the trade-offs for that sophistication, you've got to run them over the whole globe, is that you can't run them at a very high resolution. So they're pretty coarse in scale. So for example, your typical global climate model isn't going to tell you much, isn't going to be able to really tell the difference between Snoqualmie Pass and Seattle. So they're really coarse in that way. So we can't use them to ask, what's the future of stormwater for Enumclaw? They're not going to tell us that in a reliable way. So then we got to do this thing that we call downscaling. I don't really like that word, but it's basically just meaning taking that information that's at that coarse scale, not usable for doing local planning, and bringing it to a finer scale. So the only reason for telling you that whole bit is just so you know, you've heard this word downscaling, you know it's a thing, right? I don't think we need to go beyond that at this point. Okay, so we did some downscaling. We ran some regional climate models on a finer scale I should say doing, actually. We haven't quite finished these. We're attempting to finish these projects. We're doing it with the city of Everett, King County, and Thurston County, and also the Port Gamble Slalom Tribe. And basically what they funded us to do is run some regional models to get these sort of downscaled estimates of future climate and then assess what those mean for stormwater. So what you're seeing here in this map is all of the rain gauge stations from these different jurisdictions that we've gotten data for. And then we're assessing changes in hourly precipitation for each of those places. So there's some technical details here, but we're basically looking at what does precipitation look like at time scales. We can't go sub-hourly, unfortunately. I know for stormwater sometimes you want to, but we can at least get to hourly, whereas we used to be doing daily, which wasn't nearly as useful. So then we can just look at how does, say, the hourly 25-year rainfall in the town of Duval, how does that look in 2100? Okay, so I want to show you how to get to this on our website, and then we'll go through this questionnaire that I've got. So this is our website. This happens to be really easy to remember, and I've got it on my last slide so you'll be able to see, and that's why I wanted to just show you. You navigate to it through these menus on the top. We've got this tab called Analysis Tools. If you go to there, it brings you to this. You can find this tool. And so this is a tool we put online. You can get the raw data, you could do more, but as a quick look so that people can start looking at what we're talking about. And I know you can't read these details, that text is really small, but what this is showing is the percent change from two different models of hourly precipitation. In this case, it's hourly. We've got it for 6 hourly and 3 hourly. For the 2, 5, 10, 25, 50, and 100-year events. So you can see that they're increasing. In this particular case, it's increasing a lot with one model and not by a lot with the other. that's one of the things we'll talk about with the questionnaire. But the point is you can sort of browse and get some results. And we've got some other stuff in here. So this is one way of looking at it. We've also, oops, there we go. Percentage change, time series change. You can see what's changing over the century. We've also put it into intensity, duration, frequency curves. I think probably many of you are familiar with these. It's something engineers use a lot in design. Same information, just different form. And then we're also including some information on how that compares with the observation. How good is our model, basically? So hopefully a starting point to thinking about and using this information. I'll stop here. This has all 3 tabs. And then I didn't note it, and it's way, way at the bottom. But there is the URL here if you do have internet and you want to look at it right now. You can go ahead and browse. All right, so, oh, and let's see. Go ahead. You can scroll down to the, we can actually browse through it. This is great. I forgot about that. Yeah. So here it actually is. So you can pick those menus on the side. Like, so if you go to that top menu, Adam, there, that just tells you if you're looking at King County, Everett, or Thurston County gauges. So you could pick, say, I don't know, does anybody want to pick one in particular? Let's do King County. And then you can pick a station, and any one of those is fine. And then you get the results. And then you can decide, do you want to look at 1 hour? Let's see. Or do you want to look at winter? This is the season you can look at. So we can look at winter or summer precipitation changes so that you can see how it's different. And then you can look at 1 hour, 2 hour, 3 hour, and so forth precipitation. So it's easy to browse. He's scrolling right now through. He was looking at 2030s, and now we're looking at the end of the century, the 2080s. So that gives you an idea of what it looks like.